Something truly remarkable has been discovered using the James Webb Space Telescope. Light beams that appear to emanate from a city center but originate in a location light years away. The possibility of extraterrestrial life has rekindled since this discovery was made. Strange, brilliant flashes of light were observed as the telescope focused on Proxima Centauri b, the closest exoplanet to our solar system. Could these signals be from an extraterrestrial civilization? Keep an eye out for further developments. The idea of life beyond Earth has captivated scientists and everyday people for a long time. There has been a lot of excitement over any evidence that life exists in space. However, the James Webb Space Telescope's clear evidence that life exists in the universe marked a turning point in history. This powerful telescope made a remarkable discovery while searching the depths of space. It discovered lights that looked like those from extraterrestrial cities on a faraway exoplanet, raising the possibility that an extraterrestrial metropolis existed there. The scientific community is very excited and curious about this idea because it could be the breakthrough they've been waiting for. In ways that we are only beginning to investigate, it suggests that civilizations are run by intelligent beings. NASA engineers are astonished by these city-like lights from a remarkable distance of 4 light-years away. They wonder how long they may have been visible in space while we waited for our technology to advance to the point where we could detect them. The planet where these lights were found, according to Columbia University astronomer David Kipping, is particularly intricate. Due to its unique relationship with its host star, Proxima Centauri, this exoplanet behaves differently than most rocky planets, which absorb sunlight and emit energy as infrared radiation. The significance of the James Webb Space Telescope is made clear by this finding. In order to comprehend the planet's atmospheric conditions, its capacity to capture infrared wavelengths was crucial in identifying Proxima Centauri b's unusual behavior. With the intention of determining whether or not this planet is habitable, researchers plan to continue using the telescope to examine the atmosphere in greater depth. Because it is particularly sensitive to infrared light, the James Webb Space Telescope can observe Proxima Centauri b even at night. In the vast darkness of space, it is difficult for numerous telescopes to detect even faint light. However, even the tiniest glimmers can be picked up by the Webb telescope with ease. Because of this, it is an excellent tool for determining whether or not the alleged city lights on the dark side of Proxima Centauri b are real. The telescope is able to detect artificial light in space as long as it falls within a very narrow frequency range, much smaller than that of regular stars. Proxima Centauri b's environment is significantly influenced by its dynamic interaction with its star. It draws a lot of energy from Proxima Centauri, like many other planets that orbit stars. The planet experiences day and night cycles as it revolves around the star. Similar to Earth, the planet experiences daytime scorching heat and nighttime cooler temperatures. Proxima Centauri b has a wide temperature range, primarily due to its composition. For instance, if the planet had an atmosphere, the daytime temperature would be extremely different from nighttime, with hotter temperatures on one side and colder temperatures on the other. Astronomers are particularly interested in this striking thermal fluctuation because it sheds light on Proxima Centauri b's atmospheric composition. With its ability to image in the infrared spectrum, the James Webb Space Telescope can effectively examine the planet's thermal emissions, providing insights into its atmospheric properties. Interestingly, the James Webb Space Telescope's orbit around Earth coincides with Proxima Centauri b's, making it possible for researchers to observe the star's daylight cycles in detail every 11.2 Earth days. The next step, assuming Proxima Centauri b has an atmosphere, will be to examine its chemical composition to see if it could support life. The presence of elements like oxygen, methane, and water vapor would indicate the existence of life on the planet. This would necessitate the intricate study of light passing through the planet's atmosphere. The James Webb Space Telescope is designed primarily for other purposes, but it excels at characterizing planetary atmospheres. The concentrations of methane, carbon dioxide, and water vapor are its specialties. However, it lacks the ability to detect free oxygen, an essential sign of life. The telescope can still look for other important indicators, like ozone, which indicates a healthy atmosphere. The search for distant worlds continues as scientists examine the James Webb Space Telescope's data. The search is getting us closer and closer to finding out if we are the only ones in the universe. It is essential to keep in mind that the James Webb Space Telescope is limited in its ability to observe the exoplanets closest to Earth. Astronomers will rely on ground-based observatories like the Extremely Large Telescope, ELT, which will begin operations in 2027 for more in-depth studies of planetary atmospheres. The objective of the ELT is to provide a more in-depth look at the atmospheric structures of distant exoplanets, as well as data that is both clearer and more specific regarding their potential to support life. Future space telescopes like the ELT are eagerly anticipated by researchers. In the interim, the James Webb Space Telescope continues to be an extremely useful instrument for examining distant exoplanets. The Webb telescope continues to provide crucial information that may alter our understanding of what exists beyond our solar system. Despite its limitations, future space telescopes are the subject of ambitious plans from researchers. In order to improve their ability to observe the planets in their orbit, they want to develop technologies that reduce starlight interference. These upcoming telescopes will be able to focus on the faint light reflected by exoplanets, making it easier to examine their atmospheres and determine whether they could support life, similar to blocking the sun with your hand to see better. However, this job is not at all straightforward. Stars shine so brightly that they frequently outshine their planets. The faint light that planets reflect, which is necessary for studying their characteristics, is difficult to detect due to this brightness. Scientists are developing a number of novel solutions to this problem. The use of coronagraphs is one such strategy. These devices are installed inside telescopes to allow planet light to pass through while blocking starlight. Coronagraphs can significantly reduce the brightness of the star by carefully shaping the light waves, making it easier to detect the dim light of exoplanets. The star shade, a massive, flower-shaped spacecraft that will fly in formation with a telescope tens of thousands of kilometers away, is another promising strategy. The star shade prevents starlight from entering the telescope and only allows exoplanet light to reach the instruments. Planets that are liquid and located in the habitable zone of their stars may benefit most from this method. Water and perhaps life might exist. However, these cutting-edge technologies call for extraordinary accuracy. For instance, over vast distances, the alignment of a star shade must be flawless to millimeters or less. In addition, these innovations must overcome the constraints imposed by space missions, such as the requirement for miniaturization, energy efficiency, and the capacity to withstand harsh space conditions. The enormous potential rewards outweigh these challenges. Biosignatures, or chemical indicators of life, such as oxygen, methane, or water vapor in particular ratios, could be discovered by successfully observing and analyzing the atmospheres of exoplanets. These molecules may indicate biological processes, implying the existence of life beyond Earth. Additionally, researchers are looking into ways to directly and more precisely image distant worlds. Advanced adaptive optics, which adjust for distortions caused by Earth's atmosphere or the telescope's movements, may be included in future telescopes, resulting in sharper images. These advancements, when combined with techniques for blocking starlight, may make it possible for scientists to not only locate exoplanets, but also map their surfaces and investigate their climates. Our quest to answer one of humanity's most fundamental questions has made a significant leap forward with the development of next-generation space telescopes. Are we the only ones in the cosmos? We are getting closer to finding out if life exists, beyond Earth, by improving our ability to observe these faraway planets. This could change how we see our place in the universe. Space exploration and the search for life beyond Earth are moving at a rate never before seen. The James Webb Space Telescope is ushering in a new era of cosmic discovery as astronomers and scientists delve deeper into the mysteries of distant exoplanets. Astronomers are using the information it collects to make groundbreaking discoveries about the structure, composition, and possibility of habitability of distant worlds. We get closer to the ultimate question with each new piece of information. Is there life beyond our planet? The discovery of Proxima Centauri b is just the beginning of what could be a significant turning point in our understanding of extraterrestrial life. Since it is the star closest to our solar system, Proxima Centauri b has been the subject of intense research for many years. However, up until this point, the aspiration of many scientists was to discover tangible evidence of life, such as artificial light or signs of civilization. The Webb telescope's detection of such light only raises the possibility that we will one day communicate with other intelligent life forms in the universe. The public's imagination and scientific curiosity are stoked by this kind of discovery, which encourages future generations to consider possibilities beyond Earth. In addition to looking for artificial lights, the James Webb Space Telescope is also focusing on planetary atmospheres, their chemical compositions, and how these could support life as it continues its observations. If you want to know if these planets have the right conditions for life, you need to look for biosignatures like methane or carbon dioxide in the right concentrations. In a way that no other telescope has been able to, the Webb telescope can examine these atmospheric components, shedding light on the possibility that distant worlds could support life similar to Earth's. Proxima Centauri b's location in the BO star's habitable zone, where conditions might be ideal for liquid water to exist on its surface, is one of its most intriguing features. The region around a star, known as the habitable zone, contains temperatures that are just right, not too hot or too cold, for the formation of liquid water. This is considered a critical factor in determining whether a planet could harbor life. The discovery of an exoplanet within a star's habitable zone is a key target for future missions, because water is necessary for life as we know it. Future space telescopes will also focus on the intricate relationship between exoplanets and their stars, in addition to finding planets that support life. Proxima Centauri b is an example of a tidally locked planet, with one side always facing the star and the other side remaining in darkness. This could result in extreme temperature differences between the planet's two sides, which would have an impact on the climate of the planet and its potential to support life. Astronomers must be able to assess the likelihood of habitable environments on exoplanets by comprehending these conditions. Another significant step forward in space exploration is the development of technologies that can block stars' bright light. It would be nearly impossible to observe the faint glimmers of light emanating from distant planets if it were not possible to block out starlight. By obstructing the overwhelming brightness of a star, the coronagraph and starshade technologies mentioned earlier are prime examples of how scientists are overcoming these obstacles. Telescopes will be able to detect the faint light that planets reflect, which could reveal important information about their surfaces, climates, and the possibility of life there. The idea of directly imaging exoplanets is another exciting development in this field. Astronomers hope to acquire high-resolution images of planets as they revolve around their stars with the assistance of cutting-edge adaptive optics and technologies for blocking starlight. In addition to offering a more in-depth understanding of the planet's composition and atmosphere, these images could also provide a more intimate view of the planet's surface features like oceans, continents, and weather patterns. We would be able to study exoplanets and arrive at well-informed conclusions about their potential to support life if we had access to this kind of imaging. The James Webb Space Telescope and subsequent missions will play an essential role in our ongoing exploration of the universe and our quest for proof of life beyond Earth. Our understanding of the cosmos is being transformed by the telescope's ability to detect faint signals from distant planets, examine their atmospheres, and investigate their potential for habitability. We are on the verge of making discoveries that have the potential to reshape our understanding of life in the universe thanks to advancements in technology and a body of research that is constantly expanding.